Hi, welcome to this video on doing t-tests for differences in means using Microsoft Excel. Let's start with a reminder of when we use t-tests. As you saw previously in the other videos, we use them when we want to know if there is a difference in means between two groups in the population. And remember that we use hypothesis tests to make sure that the results we observe in the sample are not just the results of sampling error. We do a hypothesis test to rule out the possibility that what we observe in the sample is just because of sampling error, and it is because it's happening in the population as well. So let's work on an example. Suppose that I have a research question, and that is, does average GPA for CHHS students vary by gender? Right? Are the GPAs for female students different than the GPAs for male students, right, in the population of CHHS students? And suppose that to answer that question, I have sample data. I have 50 randomly selected students that were surveyed and asked about their GPA. And I have that data set here. Suppose that this is the Excel file that has the data set. I have 50 participants. They were all asked about their GPA and their gender. Right? So how do we go about that? Before we start, let's just explore the data a little bit. Let's sort the data by gender and just have a look at the data. So to do that, I go to Data, Sort. My list has headers, good. And I'm going to sort the values by my variable of gender. Okay, so the first observations here, you can see now, you have first observation is the one that didn't answer the gender or the GPA. So the second observation starts with all females, and that's their GPA for all females. Then there was one observation that filled that incorrectly, and then there was all the males. Okay, so just by taking a look at it, it seems that female students would tend to have higher GPAs. There are a lot more male students in this sample than there are female students. But anyway, we'll find out what the results are in the sample and whether those are also taking place in the population. So, these are the steps that we will follow. First, we'll determine the appropriate t-test we need to use. Then we'll state the null, an alternative hypothesis, decide the significance level, and calculate the sample results, right? Sample mean, standard deviations, sample size for each group, calculate the degrees of freedom for the test, obtain a critical value, obtain a p-value for the test, obtain the test statistic for the test, and interpret the results. We'll do all this in Excel. So first, remember from a previous video, we need to determine what type of test we're going to use. We asked ourselves, are the samples matched? In this case, the sample of female students are not matched to the sample of male students, right? They are not matched, they are not paired. The composition of one doesn't depend on the composition of the other. We cannot pair them one-to-one, so the samples are not matched. The answer here is no. So we're down to these two types of tests. Now, are the variances for each group equal in the population? Well, we don't really know that. So we will calculate both tests. Right? We'll use a test for non-paired unequal variances and a test for non-paired equal variances. Right? We'll start with this one. We'll assume that they have equal variances and see what happens. All right, so stating the null hypothesis and alternative hypothesis is the first step. That's one of the most important steps in any hypothesis tests. So as you will recall from previous videos, the null hypothesis here is that the mean for group 1 is equal to the mean for group 2 in the population. In other words, that the average GPA for female students is equal to the average GPA for male students in the population. That's our null. And the alternative, because we'll use a two-sided alternative and non-directional, we'll have that the mean for group 1 or the mean for females, the average GPA for female students is different than the mean GPA for male students in the population. Right? I have that here. I stated my null here that the average GPA for male students is not equal to the average GPA. Oh, I'm sorry. Whoa, this is. You see, this is the null is that they are equal. Right? The average GPA for male students is equal to male students, and the alternative is that the average GPA for male students is not equal to the average GPA for female students in the population, right? And the population is all CHHS students. Okay, good. So step 2 is to choose a significance level. Step 3 is to choose a significance level for your test. Recall that by convention, we give ourselves at most 5%, right? In social sciences, in some cases, some researchers won't go above 1%. For us, we'll choose 5% or an alpha of 0.05. Okay. So let's go here and we'll say significance level, that's going to be 0.05. Good. Now we go to obtaining our sample results. We need to obtain our sample means, our sample standard deviations, and the sample sizes for both groups. Right? And we're going to do that with pivot table. So we're going to first insert the pivot table, right? And we go to data, right? And then pivot table. For those of you using PCs, the pivot tables will be on the insert menu. Right? It selected the entire data, and I'm going to put that pivot table. I'm going to put it here and click OK. GPA into the values. Okay. And then the variable gender or sex into the rows. Okay, now you can see the table there. It's already done. We have blank observations and those that are incorrectly filled. We're going to filter those out because those guys didn't give us any GPA. So this is the count, right? That is the number of observations there. I'm going to make a little table here to record all these results. Here's going to be the sample size for each group. Now we have for females we have 20, and for males we have 27. Now we're going to ask for the average GPA and the standard deviation of GPA. How we do that? I'm going to do a right click here on the numbers, field settings, summarize values by average. Summarize values by average. And OK. Okay, so the average GPA for female is 3.62. The average GPA for males, 2.79. Now I'm going to ask for the standard deviation. I'm going to go click right again, right click, then field settings, then standard deviation, and OK. Now the standard deviation for the variable GPA for females is 0.39. Let's put 0.39, rounding up, and for males is 0.38. Very similar standard deviations. The average for females is considerably higher than the average GPA for males in this sample. Right? And those are the sample sizes. Good. All right. So we have the sample results now. We know that in the sample, at least, female students have a higher average GPA, right? And these are the steps we follow. We inserted a pivot table, we chose the variable of interest, and dragged it into the values box. Then we chose the variable, identified it into two groups, and dragged that into the row labels box. And then we clicked on the table and chose summarize values by. We used average to get the mean of the average, standard deviation to get the standard deviation, and count numbers to use the sample sizes. The next step in the t-test is to calculate the degrees of freedom for a test. And those degrees of freedom will vary depending on the type of test we're using, right? So if we're using an equal variances t-test for non-paired, we don't have paired samples. So we have one of these two. The degrees of freedom for unequal variances would be the sample size for the first group, for females, plus the sample size for the second group, males, minus 2. Right? And if we're using a type 3, we would get the sample size for males, minus 1 of these two. Right? So, let's put here degrees of freedom. And we're going to assume that we're using an equal variance test, the second one, right? We're going to assume that we have this one for now. So the degrees of freedom are given by n1 plus n2 minus 2. That is, this is n1 plus n2 minus 2. Right? So this will be equal to that plus that minus 2. And that's the degrees of freedom. That's 45. Right? That is assuming equal variances. If we were assuming unequal variances, the degrees of freedom will be given by either this minus, by the lower of this minus 1 or this minus 1. Right? That will give us 19, this will give us 26. So the degrees of freedom, assuming unequal variances, would be 19. Right? For now, equal variances. Assuming equal variances. Good. The significance level that we chose, 0.05 or 0.01, we're going to use this one. And the degrees of freedom for the test. Right? So let's go back to here. And critical value of t, we are going to use t inverse, and then we're going to put the significance level, right, which is 0.05, 0.05, and the degrees of freedom, and there are 45 in this case. Right. That is our critical value of the t-statistic when the null is true. Now let's keep going. Now we go to obtaining a p-value for the test. But I'm going to have to stop this video here to have it under 15 minutes, and I'll continue on part 2. See you in a little bit.